M06. Two characters in a line of G-code. When it works, the machine swaps tools in 3 seconds and nobody thinks about it. When it skips, you put a 1/4-inch end mill into a part that wanted a face mill, and you've just scrapped a 4-hour job. Here's what M06 actually does, and why a missed tool change is the bug every machinist watches for. M06 is a miscellaneous function code. The M stands for machine function, anything that controls a physical action that isn't motion itself. G codes move the machine. M codes tell the machine to do something. M03 starts the spindle. M08 turns on coolant. M06 changes the tool. But M06 by itself doesn't tell the machine which tool to grab. That's the T-word's job. T05 selects tool 5. M06 executes the swap. On most controls, you write them on the same line and the machine reads T first, then runs M06. Now here's the part that matters. M06 isn't one action, it's a sequence. Spindle stops, coolant shuts off, the Z-axis retracts to the tool change position, the carousel or umbrella indexes to the requested pocket, the ATC arm, if it's a double arm changer, swings in, grabs the old tool from the spindle and the new tool from the magazine at the same time. Drawbar releases, the arm rotates 180 degrees, drawbar clamps, the arm retracts, spindle reorients, M06 complete. All of that has to happen in order. Every step has a sensor or a limit switch confirming it finished before the next step starts. When machinists say M06 skipped, they don't usually mean the line was ignored. They mean one step in the sequence didn't confirm, but the machine moved on anyway. Maybe the drawbar didn't fully clamp. Maybe the carousel indexed to the wrong pocket because of a worn cam. Maybe the tool length offset never loaded. The machine thinks it's holding tool 5, it's actually holding tool 3. Or it's holding tool 5 with no length compensation. Either way, the next G01Z move plunges into something it shouldn't. Best case, you break a tool and stop. Worst case, you crash the spindle into the vise and bend the column. That's why shops obsess over tool change reliability. Daily checks on the ATC, greasing the carousel, verifying drawbar pressure, probing tool length on every load. Some shops run an M00, a program stop right after every M06 on critical jobs, so a human can visually confirm the right tool is in the spindle before motion resumes. It costs 5 seconds per tool change. It saves 4 hours scrapped parts. The math is obvious. So M06 isn't just a tool change. It's a contract between your program and your machine. You're trusting that every sensor, every clamp, every offset behaves exactly the way the sequence says it will. When that contract breaks silently, the machine doesn't know. 2 seconds too late. If you've made it this far, you already know more about what M06 really does inside the spindle than most people on the shop floor. Subscribe. New videos every day on how the trades actually work.